Hello, everybody. We are coming back with this with the Linear Talk cycle, and in this case, we are going to talk about emojis. Emojis appeared a long time ago. I remember when we used them. We used to use them in MSN. I think it was the first time that I saw an emoji. I don't actually remember, but yeah, it was kind of like 25 years ago, or 20 years ago, or maybe less. Yeah. I don't know if you remember when your sister sent you a message and it had a lot of emojis inside of the message because people used to replace word with emojis, and it was kind of annoying, right? With the big old emojis. Yeah. And so yeah, we are here with Valentin and Stanislao that are going to tell us a little bit about of emojis and the history behind them and how they work. So, all your guys.
Yeah, thank you, JC. Well, today the topic is emoji, as Juan Cruz said, and we're gonna tell you why do we think that they are not just pretty faces, right? So, awesome. So, my name is Valentin. I'm a software engineer. I'm also a front-end developer here in Lenio Labs.
Hi everyone, I'm Stanislao. I'm also a software engineer, and I'm also working as a front-end developer here at Lane Labs.
Awesome. So I take the blame, and I will tell you guys how this topic came up. So I was procrastinating on Twitter and found a tweet about a guy finding really interesting how emojis were being handled by the spread operator in JavaScript, right? So I grabbed that tweet, posted it in the JavaScript channel. We got a lot of reactions and replies. And I proposed doing a Shayas talk, right? Well, it ended up being a linear talk. So here we are. Bear with us. I promise it's going to be really interesting. Okay, so I want to play a game with you guys. I want you to guess the length of the following strings in JavaScript. First, we have the string containing the word hello, and a string 2 containing the word hello, and emoji of a farmer, right? So we're gonna print out both of the lengths, but before doing that, I will take the first guess, and I will say that the first string has a length of 5. Do you agree with me, guys? I believe so. Okay. Yeah. So let's see. So I'll let you guys tell me what do you think the length of the second string is. I would say 5 from the hello, 5 from the hello in the space, and the emoji, right? Some of you say 8. Let me take a look at the chat here. 8, 7. Okay, yeah. 10. Okay. Okay, that's pretty interesting. So let's take a look at the outputs, right? We get a 5 and an 11, right? That's pretty weird. And today, Mario said 11. Okay, so today we're gonna have an answer for this question, and yeah, thank you, Stani. But also I wanna see how JavaScript manipulates strings. This is something Stanislaus gonna talk about a little bit later. But let's see how the split method and yeah, without Unicode, good. How the split method and the spread operator work, right? So we have the family emoji here. Yeah, there's a family emoji, and if we print the outputs of the method and the spread operator, you will see that we get an 11 using the split with an empty string, right? And we get a lot of emojis, right? When printing the output of the usage of the spread operator, right? So I find it really interesting because sorry. Yep. I find it really interesting because we can see that in the first output, we get some kind of codes separated by blank spaces, right? And just take a look at those codes, and you'll find out that those come in pairs, right? It's pretty interesting. And also, when taking a look at the output of the spread operator, you will see that somehow that's the combination of the family members in the first emoji, right? Can you see that? So we have a man, a woman, right, and two children, right? So that's a combination, kind of. So in order to understand this, and in order to give an answer to this question, let's talk about text and how computers interpret text, right? So most of us know, most of us have a technical background in computer science, right? Most of us are JavaScript programmers or Java programmers, and you know that computers deal with numbers, right? So these characters, in order to be encoded, are assigned to a number. Right? So in ASCII, that's an encoding system. The uppercase letter A takes is assigned to the number 65, right? And it's binary representation of a 0, a 1, followed by 5 zeros and a 1, right? Yeah, let's go to the next one. So, ASCII only takes 7 bits for encoding, and 7 bits, it's about 128 combinations of different characters, right? So it's not enough for considering the whole plane of numbers of characters we use on our daily basis. We have different languages like Japanese, Chinese, the Cyrillic writing system, right? We have a lot of scripts like Latin. So 128 combinations or different characters is not enough. So we had, back in the days, different encoding systems that coexisted. But the issue there was that they were not compatible, right? Because different writing systems were assigning different numbers for the same character, and the other way around, like, right, same numbers for different characters. So they needed some kind of mapping tables or source maps for handling communications between different encoding systems. Also, as I already said, we had different languages which were taking different encodings, right? And we had also servers or devices like servers that were handling requests all around the world, and they needed to support different encoding systems using these mapping tables, right? So there was a lot of risk of data corruption. So a standard was needed, right? So that's how Unicode came out. Unicode stands for Universal Character Encoding, and it's a standard, right? It provides a unique number for every character, and it's widely adopted by all modern devices, applications, and platforms. When I would say applications, devices, application, or platforms, we're telling mobile phones, operating systems, web applications. So I'll tell you guys, why do we think that Unicode is incredible? Well, first off, it provides support for all characters, modern and ancient. It also provides a common located data repository, or CLDR. And let's take a look at that. This repository allows translations of mass, date, and time. But for emojis, in this case, it provides short names, right? Describing names for every emoji. In this case, we have a woman in a wheelchair, right? And the short name that Unicode provided is a woman in a motorized wheelchair, right? This is not only helpful for search engines, but also for assistive technologies like screen readers that are describing what we are seeing on the screen, right? And Unicode also allows combinations of other characters, and we're going to call this grapheme clusters, right? So let's take a look at the woman in a motorized wheelchair, but with some kind of skin tone modification, right? A skin tone modifier, right? So this woman in a wheelchair is a grapheme cluster, and it's the result of the combination of the emoji of a woman followed by a Fitzpatrick skin tone modifier. Fitzpatrick is a scale from 1 to 6 of the different skin tones, right? Then we have a zero with joiner. That's another Unicode character. We're gonna talk about that Unicode character later. And we have the motorized wheelchair emoji, right? All of those combined create this woman in a wheelchair with some kind of skin tone. And also, it's not only helpful for emojis, but also for everyday texting, like everyday characters we use. For example, in Spanish, we use this letter that's the E with an accent. And this is a graphene cluster as well that is the result of a combination of the letter E plus a combining acute accent. That combining acute accent is another character, another Unicode character. Okay. So, no, yeah. So, Unicode is also backwards compatible with ASCII, right? In UTF-8. Unicode does not only allows UTF-8 as an encoding system, but it also allows UTF-16 and UTF-32. Right. So let's answer the question we saw at first. Right. We're gonna apply the split operator with an empty string on the farmer emoji we saw on one of the first slides. But before answering that question, we need to understand, we need to know that JavaScript uses an encoding system, right, for their strings, right, for its strings. In this case, JavaScript is using UTF-16, right? And the method UTF-16 has to encode different characters, allows characters to be encoded using both 2 and 4 bytes, 16 or 32 bits, right? And how can we determine if those characters are going to be encoded using 2 or 4? Well, we have in Unicode, we have different planes. For the most commonly used characters, we have the BMP, that's basic multilingual plane, right? That's enclosing all the most commonly used emojis, characters, and those get encoded using a single code unit or 2 bytes, right? And the characters that are less commonly used, for example, emojis, are in another plane that's called the astral plane, right? And those get encoded using 4 bytes or 2 code units, right? As we can see here on the first half of the array, right? That emoji of a man gets encoding using 2 code units or 4 bytes, 32 bits. And those code units we are seeing are called surrogate pairs, right? So the first code unit is the lower surrogate pair, and the code unit on the right is the higher surrogate. Okay, so that kind of answers our question, right? We already see that some emojis, I don't remember if we saw that, but some emojis are the result of the combination of other emojis, right? As the woman in a wheelchair, that's a graphene cluster, but some others are just they just exist by themselves, right? So in this case, the farmer emoji is a graphene cluster, and is the result of a combination of an emoji of a man plus a zero with joiner and a sheaf of rice, right? So that's zero with joiner. It's a way that Unicode has to tell developers that that the characters combining are going to create a single character, right? So it's a combination. Is somehow it's telling you that we are going to create a new character based on a combination of others, right? And a zero with joiner it's also a valid Unicode character, right? But it gets encoded using just one code unit, right? It's in the BMP. We can go to the next. Yeah. So I know what we already seen. It's kind of messed up. It's kind of difficult to understand. But we're gonna have a question section. So bear with us. And now I want to tell you a brief history of the emojis, how they were created, and who was the one that created them. This guy on the right is Shigetaka Kurita. He is considered the father of the emojis. And in 1999, he was working for this company called Docomo. Right. He realized that a lot of people were sending text alongside with some kind of image, and he proposed adding 12 by 12 pixels images to the text. There's some kind of images embedded in text, right? So he basically grabbed a number that wasn't being used, right, of the encoding, and assigned it to an image, right? In the year 2000, there was a proposal from the company he was working for to add the emoji to the Unicode standard. But since they were really popular in Japan and was nothing to do with the rest of the world, and there was no support from the company on adding this emojis to the standard, no action was taken. Right? In the year 2000, nobody cared about the emojis. But as communications and texting across the world was surging, folks in Japan started sending emails or text messages to folks in Argentina, United States, or even Russia with emojis that couldn't be rendered because the mobile phone provider wasn't supporting this kind of characters, right? They were like some kind of private use only for Japanese people, for Japanese folks. So Google started working on adding this set of emojis that were widely used in Japan to the private codes or the codes that were not assigned to any other character in the Unicode standard. But they faced a lot of issues. So yeah, and it's not also recommended by the Unicode. I mean, Unicode has some characters or some code points that are not assigned to any other character, but it's not recommended from the Unicode consortium. So Google started working alongside with Unicode in order to make a proposal of considering those emojis in August 2007, and the first version or the 5.2 version containing all the new emojis was released in 2009.
Yeah. Mute yourself.
Yeah, I'm going to mute myself, and Stanislav is going to grab the mic.
Okay, so
oh, sorry.
Okay, so now that you know emojis history and that Unicodes manage them, you may be wondering if you can propose new emojis, and if you can, how you can do that, right? Well, Unicode provides us a guideline with a specific process and a format to do so. We have to fill a form, and Unicode provides us a guideline where we can see how we can fill it. What we are going to do now is we are going through an example, and we are going to see how we can fill it following this example. First, we have to provide a title of the proposal. Then we have to provide the submitters of it and the date that we are submitting this proposal. For this example, we are taking the shaking face emoji, and first we have to identify it. To do so, we have to provide a sample image and alternative images for it. We also have to provide the CLDR name. In this case, we are providing the shaking face. As Valentin mentioned today, the CLDR name is the name that Unicode uses to distinguish or to know what emoji we are talking about. Also, we have to provide some English shortcuts or keywords that people can use to find our emoji. And also, if it has, we have to provide the closest emoji that's similar to our new one. Then we have to provide images for it. We have to provide 2 images in 2 different sizes. We have to provide one in color and another one in black and white. the black and white one cannot use grayscale. That's important. We have just to use black and white. And we have to provide them in 2 different sizes, one for 72 by 72 and another one of 18 by 18. Then we have to provide the category where our emoji is going to be placed. In this case, the shaking face will be placed in the face neutral skeptical category with another emojis. And then we have to talk about the selection factors, both inclusion and exclusion. Here we are going to tell Unicode why we think that our proposal, our emoji, should be in the next version of Unicode version. First, we are going to go through the inclusion factors. Here we are going to talk about the compatibility. This means, for example, when our emoji is already being used in another social media application, social media network or platform or operating system, or anywhere you think that this emoji is already being used, it will help Unicode to say, okay, this emoji is being used and a lot of people is using it. Then we have the expected usage level, expected usage level, where we are going to say Unicode why we think that it's gonna be widely used. Here we have to provide some images of other media where the people are using it. You can provide magazines, mangas, anime, movies, wherever you already saw this emoji, you can attach images of it. You can also provide some examples of how people will use this new emoji. And also you can use, for example, Google Trends or Google Search. You can just Google shaking face and see how many search Google has for it, and take a screenshot and attach it to the proposal. Then we have to talk about the distinctiveness. This is how easily can we can distinguish what we are talking about when we are using this emoji. I mean, an emoji should be explained by itself. If we have to explain why we are using that emoji, it has no sense. So it's important that it has some distinctiveness. And then we have to talk about the completeness. This happens when our new emoji are completing a group that already exists. Let's say that we have, for example, a yin yang group, and we have the yin yang, and we have the yin emoji, but we don't have the yang emoji. Okay, so we can say, okay, I'm proposing this yang emoji because it is completing an existing group. So it's also an inclusion factor. Then we are going to talk about the exclusion factors. For this, Unicode provides us a large list with a lot of bullets that we have to point out or answer. We're going through the most important ones. The first one is if it's already representable, if we can represent this emoji using another ones. Also, if our emoji has some logo or brand or other third-party IP, this will help Unicode to know that if they add this emoji, they may will have problems with copyright with another company or whatever. Also, we have to point out if it has text. The idea is that an emoji doesn't include text because it should be explained by itself. Also, if it's on a variation on direction, for example, if we have a guy that's running to the right, it has no sense to propose an emoji of a guy running to the left. So we have to point out that too. And then we have the open-ended, which is the opposite of completeness. Here we are saying, for example, that we are opening a new group, that it's going to be incomplete in this new version. For example, we are proposing the yin emoji, but we are not proposing the yang one. So we are opening the yin yang group, but we are not completing it. And then the last bullet is other information. Here you can provide Unicode, or you can tell Unicode whatever you think that's important, or why you think that this emoji should be also in future versions of Unicode. So now let's talk a little about Unicode and JavaScript. As Valentin showed you today, when you use split and spread, split method and spread operator to a text, results are different. But why are they different? Well, the main difference between them is that they use different iterators. While the split method uses an non-Unicode aware iterator, spread does. That's why when we split a text with an emoji, the spread operator will know that we are talking about emojis, or not emojis, but an Unicode character that uses surrogate pairs. So that's why when we split that former, we are going to have a man, a zero with joiner, and a corn, and it will not split that man and that corn in two separate code units. That's what Valentin mentioned today. So let's say that, for example, we want to create Lenny Twitter, and we want that the tweet length matches with the
yeah, we want to limit the length of the tweets, right?
Yes, we want to limit the length of the tweet, but we want that the length of the tweet matches with the user's
perceived characters.
So for example, here, when we have hello plus farmer, we want that the length of the tweet has to be 7 in this case. So as we saw today, when we use the split, we get a length of 11, and when we use the spread operator, we get a length of 9. And how can we get the length of 7, the one that we are expecting? Well, Intel to the rescue. The Intel option, for the ones who don't know, is the namespace for the internationalization API. It provides us a lot of methods and objects that will help us to manipulate strings, dates, number, arrays in different language and in different writing systems. It's very useful, for example, when our website is growing up quickly and we want it to support different languages, and we want, for example, that the day that we are currently showing in Spanish, we want to show it in English with the English format, which is month, day, years. Well, we should use Intel because it's a good practice. Intel also provides us the segmenter object. The segmenter object is an object that allows us to manipulate strings in different writing systems. Because, for example, in Japanese or in Chinese or Korean, sometimes the space character is not always
separating.
It's not always separating words, because maybe you know that, for example, in Chinese, some words together creates a new one. For example, if you use scissors space man, it means that's a barber. But if you use it separate, it doesn't mean the same. So Intel provides us a segmenter which help us with the segment method to split this text in meaningful words. Mm-hmm. So that's what we are going to do. We are going to create a function that uses this segment object, and we are going to map it and get the segment of each segment.
The user perceived
character. The user perceived character. So here, if we use this split emoji function that we just created, we will be able to get the expected length of the text. So now you may have some question for us. I know that it may be.
We wanted this talk to be quick, so that's all for today. We can think of doing another one if there is anything you think would be interesting to address. But yeah, we are open to questions if there are any.
I have one. Can you do the reverse process? kind of like you show that you can split the emoji into their parts, but can you combine emojis in code and create and get the emoji that is the combination of those, right?
Yeah.
Kind of like doing the reverse when you split the family icon, can you reverse it to the family to the other thing?
So let's take a look at this one, this example. So you're sharing this, you're sharing this, right?
Yeah, the page.
Okay, what happens if I do this? Okay, so let's do something. Let's open,
What do you want to? Okay.
Yeah. So let's open the console and see if we write a string. If we write a string, right? And we do this. How's the backslash here? Here. So U D 8 3 E and then another backslash and U. Yeah, let's switch. The one, you will see that you get the expected emoji. So you can also do that if you use the showing method. You will see that it gets recreated. You know, so that's
Okay.
pretty interesting. Let me do this.
That's amazing.
Yeah, well, that's Unicode, right? That emoji of a man has a code point, right? But since emojis are in an astral plane, those get encoded using surrogate pairs, right? And since our browser is aware that we are using Unicode as an encoding system or an encoding standard, it's gonna understand that those characters, if the standard is properly applied, will be one single
Emoji.
emoji. This is a one single emoji.
Amazing.
Yeah, that's a pretty interesting. Any other questions?
And if in there you sum the man plus the corn, you would get like the farmer.
Well,
Yeah.
only if you use the let's do it. Let's do this. Let's do this. And can you please?
And here you have.
Okay, so it's UD8 U8
3C.
3C. See, and now we have a U
D
F 3E,
E.
right? So if we print this, you'll see that both are not getting combined, you know, and that's why we need the 0 with joiner in between, right? So this 0 with joiner is U200D, right? And if we print this out, oh, sorry.
Yeah.
You get the farmer emoji, right? So the farmer emoji, it's basically a bunch of code units all together, right? So that's the reverse path in order to build the same emoji we broke down previously.
Perfect.
Yeah. Any other questions?
So I have a question. Do you know, or someone, or you guys have submitted an application for Unicode for some emoji or something?
No.
Oh.
I don't know anyone, but
anyone?
Yeah.
Actually, a couple of years back, there was a huge debate and people pushing to get the mate icon in the Unicode set, and they made it. So it required a couple trials, but it finally was approved and incorporated.
Yeah. Okay.
I can share you a page that has all the Unicode proposals, so you can take a look at them and see if, which proposals are now. And if you want, you can take a look at them to guide yourself to create a new one.
Oh, cool. Thank you.
Yeah, it's open.
Okay.
Okay.
Should be able to vote on which ones get added.
Yeah.
Yeah.
One comment, at least, just to think about, because there are other ramifications about using Unicode, not just for emojis. The JavaScript world moves a lot faster than maybe other technologies, and especially a lot faster, like light speed compared to backend or database technologies. So in JavaScript, you may have a lot of libraries and utilities to control the length of a string, but they usually database technologies fall behind. And you need to be careful for those working in backend. You need to be careful how you size the columns, the data types in the database, and the sizes, because they usually are limited by bytes, and the Unicodes require 2 or 4 bytes depending. And you may think that you are sizing the column right, but you may have errors anyways. So in those cases, if you really want to support Unicode, you need to work closely with the backend database, the backend developers, and especially those created the databases to support it. Not all databases support Unicode by default.
Yeah.
Well-
Also the encoding system should be if you're JavaScript, we should think of considering UTF-16, right?
Well,
Yeah.
something interesting is, for example, if you go to Twitter and you try, you will see that emojis takes a length of 2, no matter what emoji you use. If it's a combination like the farmer, or if you use a man, it just takes a length of 2. I don't know how they do that,
we
but
still don't know the answer. So
yeah, we don't know the backend architecture, but they do it that way.
Yeah, because it's hard to think how much space you need in the column that is going to contain this information, because a user can have only ASCII characters or maybe just entire emojis, and you never know how much space you need to allocate for it. Maybe the worst case scenario would be the safest, but you're wasting a lot of resources in maybe space.
Right.
Yeah.
sure.
I have a question. What is the longest combination of emojis to create one emoji? Do you know?
The grapheme cluster, we believe it's the family.
Yeah, the family one.
The family, and also if
Okay.
you keep adding skin modifiers, it gets huge.
Like,
Yeah,
Mhm.
but we don't have a way of like live code it, because it will take some time. But we can share it on the JavaScript channel.
we can search for it.
Yeah,
Amazing. Thank you. Yeah.
Okay.
awesome. Okay,
So guys, is there any other question?
Okay.
I think I would like to create an emoji builder, actually, or not a builder, but something that an UI that you could pick which emojis you want to combine, right? And then whenever you select one, maybe the others disabled or something like that. That would be fun to see. I don't know if you found something like that when you did your research
No.
on this.
No, there are some websites to find emojis, but I don't know if it allow you to combine them.
Mm-hmm.
Okay.
Yeah. So that's pretty interesting. That would be pretty interesting. Awesome, guys. If there are no other questions, we can wrap it up. Thank you for joining us today. I hope you found that interesting. And if you have any questions, just reach out to us on Slack. And yeah, awesome. Thank you, guys.